In this module, we will discuss commissioning a Potter ERCES Guardian Emergency Responder Coverage Enhancement System. What does it mean to commission an ERCES? System commissioning is multi-tiered and an essential step to ensure both system efficiency as well as protecting the radio network used by first responders in their crisis communications. It will be the responsibility of the commissioning party to ensure the first responder network is unaffected by the ERCES. They are also responsible for demonstrating that the alarms and safeguards in place are working and activating properly. Along with network protection and alarm demonstration, the commissioning party must show that the ERCES is providing signal in 99% of the critical areas and 95% of the general areas of the building. They must also ensure that the passive components and hardware have been installed per the HJ's requirements. Finally, the commissioning party will be responsible for demonstrating that the BDA is properly programmed and supporting the frequencies utilized by the local first responders. One of the most important parts of protecting the local radio network is creating and understanding the uplink budget. The uplink budget is used to determine what the uplink gain needs to be on the BDA to ensure the system does not raise the noise floor, causing a negative impact on the jurisdiction's radio network. The uplink budget is determined by calculating the uplink output power of the BDA and considering the losses from cable, antennas, and the free space path loss to the radio tower. If the noise getting to the radio tower is greater than the noise floor, the BDA's uplink gain should be reduced. Another important test to conduct is called an isolation test. This determines maximum downlink gain and is performed before the donor antenna is connected to the BDA and is intended to identify potential feedback created by the indoor and donor antennas. Since this test is performed outside of the ERCES being connected to the radio network, adjusting the system does not negatively affect the radio network. If isolation is lower than required by the HJ, the BDA gain must be lowered, or the isolation must be improved by moving an indoor antenna or adding attenuation. The use of a signal generator and spectrum analyzer is required to conduct an isolation test. The spectrum analyzer will be connected to the end of the donor antenna cable to measure the effect the internal antennas have on the donor antenna signal. Inject 0 dBm of signal via a signal generator into the distributed antenna system and observe the difference on the spectrum analyzer. The difference between the measured reading and the injected test signal power is the downlink isolation. This should be 20 decibels or greater than the BDA's maximum downlink gain. Uplink isolation can be measured as well by alternating the location of the spectrum analyzer with the signal generator. While this test is not always required, it's important to know how to conduct it in case it is asked for by the HJ or the FCC licensee. When commissioning the ERCES, the HJ will ask you to demonstrate that the alarms are in proper working order and connected to the annunciator or FACP properly. For a passive ERCES system, 6 alarms must be activated. These alarms are the signal source malfunction alarm, active RF emitting device failure alarm, active system component malfunction, AC power failure, low battery capacity, and the battery charger failure alarm. The VSWR or antenna failure alarm ensures the BDA is connected to a donor antenna and that the cable and connections have integrity. To test this alarm, simply disconnect the coaxial cable on the outside or donor line. The BDA may take a few minutes to activate the VSWR alarm, but once it is triggered, you will see it on both the BDA as well as the annunciator if one is connected. To resolve this alarm, connect the donor cable to the outside port of the BDA. If the cable is properly connected, the visual and audio alarm will cease. The RF summary alarm, or BDA failure alarm, can be activated by creating feedback in the system, putting the BDA into oscillation. In order to not negatively affect the radio network in the area, you should connect the outdoor and indoor ports of the BDA. To not damage the BDA, you must add 20 decibels of attenuation between the jumper cables. This alarm can take up to 5 minutes to activate, so give the BDA time to build up its feedback detection. Once the alarm has activated, simply reconnecting the donor antenna to the outside port of the BDA will put the BDA back to its normal state. The active component alarm, or system component malfunction alarm, checks the active components for integrity and activates when overpowering occurs. since we obviously do not want to overpower the PC board and potentially damage the BDA. We can demonstrate the alarm is functioning properly by eliminating power to the PC board. On the top of the BDA, simply disconnect the power line to the PC board seen here. This alarm will take 3 to 5 minutes to activate. To bring the BDA back to normal status, reconnect the power line to the PC board. For activating the battery backup alarms, it is important that you follow the manufacturer's instructions found in their user manual. The following BBU alarm activation instructions will apply to Tower IQ branded products specifically. Activating the loss of AC power alarm is as simple as disconnecting the AC cable's supply power to the battery backup or BBU. Once the alarm triggers, the AC cable can be reconnected and the system should return to normal. To activate the low battery alarm, you must eliminate AC power and allow the batteries to deplete to 70% or less before the alarm will activate. To activate the charger fail alarm, unplug the battery connection to the BBU's main circuit board. Reconnect the battery connector to reset the BBU alarm to normal. If connected to the FACP, your alarms should show up as supervisory alerts when activated. As you activate each individual alarm, they should also activate on the FACP. If they do not, ensure the wiring has been done properly per the manufacturer's instructions. After calculating your BDA output power by adding your BDA gain to the incoming donor signal strength, you can use your signal generator to test your signal coverage without creating potential noise to the radio network. The donor antenna should never be connected to the BDA until your uplink budget and isolation test are completed and the gain of the BDA has been adjusted properly. Set the signal generator output power to match the expected output power of the BDA and inject that signal into the distributed antenna system. Use your spectrum analyzer to conduct a grid test, ensuring the ERCES is enhancing the areas that were previously failing the grid test. If there are areas that are still failing the grid test but the design calculations show that the signal should be adequate, more testing will need to be conducted. A line sweep is a great way to identify if any cable, connectors, or components are either damaged or improperly installed. One of the most common mistakes is not accounting for proper inputs and outputs of couplers and tappers. You can use your downlink budget to cross-reference the signal measured at your antennas against what it should be according to the design layout. When your testing has been conducted and everything looks to be working properly and your isolation test suggests there is no potential interference or feedback expected to be created, there can still be unforeseen noise created once the BDA is connected to the donor antenna. For lack of a better term, we call this the ghost in the machine. It's important that you notify the FCC licensee before you connect the ERCES to the radio network so that if there is any adverse effect on the radio network's integrity, the system can be powered down quickly and reduce the impact to first responders relying on that radio tower's functionality. You can use the BDA's graphic user interface, called Sentry, to see the incoming and outgoing signal strength. Once you see that the BDA is configured properly, you can conduct your final grid test and test your alarms while the ERCES is operating. A retransmission agreement will be required from the FCC license holder and must be attained before the BDA is allowed to continue operation. Much like an elevator certificate, the retransmission agreement is often a 5-year agreement and must be renewed before it expires. All Class B ERCESs must be registered with the FCC prior to operation. This is not approval, simply a registration so the FCC knows where BDAs are located in case noise is reported. This helps the FCC licensee identify BDAs potentially causing the noise issues. According to NFPA 1225, this is the list of initial acceptance documentation. Reach out to your sales engineer for any missing documents, and they will point you in the right direction. Take a moment to review this list now. Here's a list of submittal documents that will likely be required by your AHJ. Many of these things can be acquired through Tower IQ directly, while some will remain your responsibility alone to acquire. The Tower IQ's sales staff and design team can help with most elements required for submittal, seen here in orange. The ERCES will need to be maintained, and a part of that maintenance is annual testing. The focus of this annual test will be to ensure the BDA is still functioning as approved and the distributed antenna system is still covering the critical areas and general areas with signal strength. A spectrum analyzer shall be used to ensure the BDA is not creating oscillation. Donor antenna isolation shall be verified as well. Every AHJ has their own code adoptions, revisions, amendments, and even personal preferences. It is of paramount importance that you coordinate with the AHJ and FCC licensee directly and identify their specific requirements and confirm the codes and standards they have adopted. Thank you for watching this module on BDA commissioning. If you have any questions, feel free to reach out to your sales engineer, regional sales manager, or the technical sales manager of public safety.